Before I even start the session, I just want to share something that's very special to me. 3, 4, maybe it was 5 years ago, I was an intern on this stage, and it feels like it was just yesterday, but I was giving my first talk ever, and it was about Podman, and it was a much different project back then, and I had just learned about containers, and it was one of the crazy experiences of my life. I was like running around the conference center, almost like sick to my stomach because I was terrified of public speaking. And now it's 3 years later. A lot has changed. You're going to learn a lot today in this session if you're working with containers and Kubernetes. But I just want to say a big thank you for being here and to the organizers, because this is a really special conference to me. And without further ado, we're going to be talking today about Podman and in general about containers and Kubernetes for the developer or for the administrator or operationalist who wants to simplify their life, who wants to work in a hybrid cloud setting with multiple Kubernetes clusters, and at the end of the day, who wants to learn about these new cloud-native technologies. So who's excited for a fun session? Woo! Thank you so much. Now, we're going to go through a quick agenda of today. I'll introduce you to Podman and Podman Desktop if you haven't used it before. But quick show of hands, how many of us use Podman or have tried out Podman Desktop before? Awesome. Okay. Love to see it. Love to see it. Boss is going to be happy. I'm going to talk about some of the new features if you've used these projects before, but I'll also explain them if you haven't. And we've got 3 different live demos today, so if one of them doesn't work, the 2 others hopefully will. And if you'd like to check out the slides, please do. And I encourage you to try out the open source project if you haven't already. So I want to get started by showing you today, here in a second, some of the mascots of the project, as you can see right there. Now, these guys are known as selkies. They're a type of mythical seal, and a group of them is what's known as a pod, which is the same unit of deployment for Kubernetes, right? Just recently, it became a cloud-native sandbox project, so CNCF. It's incubated, and there's some implications that we're going to talk about there. Being in Atlanta, being in Georgia, of course, they're drinking some Coca-Cola. They've got the Devnexus sign. If you guys are from the South, you'll know that any amount of snow is going to close all the schools, and so they're recovering. And of course, there's traffic. You know, that's Atlanta. But I would like to talk about what's new with Podman and Podman Desktop and show you with some demos. But really quick, I want to back up and explain to you, if you haven't used Podman before, what it is. So it's a container engine to work with not just containers, but Kubernetes resources, volumes, images, much more. And the differences that you should know about it is there's 2 distinct things that make it different from, say, for example, Docker. First off, it's daemonless. So when you create a new container for your application, what's actually happening is Podman is forking itself, and that child process becomes the container. Now, this is a little bit different in a fork exec architecture than a client-server approach, where if you're using the client, say, Docker run, for example, if you lose access to that background process, that daemon, then you lose access to your containers, and so Podman's a little bit different. And because of that, you're able to run containers in a rootless fashion. Let's say you're in a bank, a large organization, and you don't have root or sudo access, you can still run containers and get the benefits there. And it's a fully open source project, and it's compatible with all of your existing container images. If you'd like to know some of the deeper differences, I encourage you to check out some cool videos that I'll list in the next page explaining what the difference is and the technologies you actually used for Podman, which essentially forks itself and uses that little conmon processing utility to ensure that the resources come back to your host once it's done. There's a guy on the left who I highly encourage watching, 10x engineer right there, and the guy on the right, who are both incredible and can explain more about the differences if you're a Docker developer and you're looking to use Podman or just Podman in general. So this is linked here in the slides. Highly encourage you check it out. Now, to catch up to what we're talking about today, Podman Desktop is the interface to let you work with your containers, to allow you to build an image, to run that container, and to connect to a Kubernetes cluster all from one singular place. So instead of going from, say, VS Code and doing my Docker build to checking out Docker Desktop and running that container, and then maybe using kubectl or another utility to connect to a cluster, we do this all in one place. And as a developer, I like to geek out a little bit. So behind the scenes, it's a really cool stack. You've got Electron, which a lot of us use for VS Code and Slack. and then Tailwind and Svelte. So if anyone watches Fireship, that's like the top tier stack out there right now. So I encourage you to try it. Whatever you're using, Windows, Mac, or Linux runs for you and allows you to, work with containers. Just recently, we've got some exciting updates. Podman is joining the CNCF as well as Podman Desktop, which host other projects such as Kubernetes. And this ensures that for organizations that want to provide Podman or a container utility for their developers, that there's going to be no license changes, which is really important. A lot of developers and organizations in 2021 had a big choice to make because Docker changed their license. And this meant that you'd have to pay per developer if you're making over, I think it was $3 million per year. And so this is a big reason that developers are seeking an enterprise-friendly way to work with containers that's open source from its core. And this means that we have more integration with all these other awesome Kube native projects such as Lima and Kubernetes and Kind and Minikube. And you're going to see some of these integrations in the live demos today. So the SEALs are happy to be joining their new home in the CNCF. And because of this, we already have a lot of integrations with Kubernetes environments from the start. So from one place where you're managing your containers, we're going to see this in action. You can also manage your Kubernetes environments. So local environments like Minikube and Kind, but also remote environments like your clusters that you might be authenticated to with your kubeconfig. And you can take those containers, you can turn them into pods, so that singular unit for Kubernetes, and deploy them straight to the cluster, whether it's development or staging, or if you're brave, production. Now, this is really cool, but I also want to talk about the extensibility, right? So Podman Desktop is fully open source and has a lot of extensions, and the ability to add your own extensions. There's an extension catalog, which we'll see here in a second, but some of them include, for example, understanding the image layer, being able to inspect the images that you have or pull. Quadlet, which allows you to take one of your images or containers and run it on a Linux system, for example, being managed by systemd. So if you don't need a full Kubernetes environment, you could generate a quadlet. And since this is an open source project, I would love if you checked it out online and let us know what you want to see, or feel free to create an issue or a PR. So please feel free to contribute. And on the roadmap, a lot of fun things are coming, but we're going to demo some of that today. So without further ado, let's get started. So here I am. I've already installed Podman Desktop locally. And you might be wondering, Cedric, you're running a Mac. You work at Red Hat. Oops. But what Podman Desktop allows you to do is actually set up a Podman machine. So what's happening is, I'll come back here, is I'm actually setting up a Linux virtual machine to run these containers. So if you're on Linux, you don't have to worry about this, but for me, this is how the containers will be run. And I have access to the ability to create clusters, connect to other ones, compose, for example. And that's really where you get started as a developer. Now, a lot of us are learning how to containerize applications, right? Or how to connect to Kubernetes and set up services, ingress, whatever it might be. So there's a learning center, and it's very helpful. But the first thing I want to do is start to build out my application from the source code. So I've got some images here, but I'm going to show you what we're working with today. And please don't be mad. I have a Java demo, but I wanted to start out with this simple Python application that we're going to be demoing for going from containers to Kubernetes. So this is a simple, guest book. Someone checks out the application, refreshes it. It's connecting to a Redis instance, so every time it's incrementing that hit counter. And we've got a Docker file here using multi-stage best practices. So we start off with a universal base image, which is optimized for Python here. And then we're going and importing the requirements.txt, setting up a non-root user. And at the end of the day, we're just doing a Flask run, and pointing to an entry point. Now, the entry point is really interesting here because we're going to show the difference between using containers and using a pod. Because with containers, we might have to do some manual configuration of ports or maybe which IP addresses it's going to talk to. And things can get kind of complicated. But when we actually turn this into a pod, they're going to be talking to each other on localhost. So let's go ahead and see that here. Now, with Podman Desktop, I've got the ability to load in images, which an image is just essentially a tarball with a little bit of JSON. So we could import that from another container engine, but I'm going to go ahead and build it but actually I have this container image already built. But it's as easy as pointing towards that container file and setting up some build configurations. WebAssembly is supported as well, which is really awesome. So I've tagged these images, and I've already pushed them to a repository. The first one I'm actually going to start off is the backend. So, we were connecting to that Redis instance. I've got that here, and this is just Redis based off of a universal base image, so we have the protection and security and certifications there. Now, I'm going to just type in Redis as the name, and we've got options in order to connect to, say, persistent volume. So we've got our data there, or we could set up a policy so that if the container restarts or crashes, it automatically comes back. Or networking, security, seccomp profiles, you name it. All of these options, as a developer, I would have to either memorize the command line utility arguments in order to build this image, or run this container can now just be automated in this one simple user interface. So we'll go ahead and start this Redis instance, and it's running here locally on our machine. I can check out the logs. Looks like Redis is initialized. And remember, we're working with containers for right now. So if I go ahead and inspect the manifest here, I'm going to look for one specific piece of information here, which is the IP address on my local host. So this is where we can connect to the Redis instance that's running, and I'm going to use that in order to connect it to the front end. So the front end is that code that we just saw for the Python application. And here, you're going to notice that it's using port 5001, while the container file had mentioned port 5000. Let's say there's a port that's already being used on your local machine. For me, this is a Mac, so I'm using AirDrop on port 5000. It's going to automatically route that to the available port, so that now I can say add that host name for Redis here and be able to connect these two containers so that they can talk to each other. So one container is running for the back end, one container is running for the front end. Fingers crossed. Whew. All right, so our little demo here is working. Both of the containers are running, and I can see the logs happening. But this is kind of the basic example as a developer of putting our containers into action, right? Building those images and running those containers. What I want to show you is the next step in transitioning to Kubernetes. Because in Kubernetes, we don't run direct containers, right? We run pods. And so the way to do that with Podman is to simply select both of them. So we'll click the front end and the back end and create this pod. So we'll call it Devnexus. Okay, yeah, pod. So what's happening here is that you're going to notice only one port is being exposed. That's because the other Redis port is inside of this pod, doesn't need to be exposed to the outside world. And now we're able to set up our applications in a Kubernetes native way. But guess what? We don't have that Kubernetes environment running yet. And so just like this, we have both of the containers running in one pod, being that containers are immutable. They've already restarted and the cache is reset. And just like this, we're able to run a Kubernetes-style object on our local machine without a cluster. Let's say we have, for example, a deployment or a service or a secret or something like that. We could actually run that within Podman itself, which is pretty neat. Or as we're going to see, we can deploy it to some type of Kubernetes environment. So that's the beginning here. So let's say I'm testing out my pod. Things are working great. What I also want to show you is, say, taking it to a local Kubernetes environment to actually test and do some development. So here I'm using Kind, and I've already gone ahead and set this up. But we could specify a Kubernetes version. And what's really great as a developer is I don't have to worry about creating the services. It's going to use Contour to actually set this up for me so that in my containers here, I can show you, we've got this Kind cluster control plane that's running this entire Kubernetes, well, simplified single node Kubernetes in a cluster. So we'll do a kubectl get pods. Uh-oh, no pods yet, so let's change that. I'm going to go back here, and we're going to select our podified application. And just like this, we've gotten a Kubernetes YAML to actually take and deploy somewhere where we're running our applications, right? So all of the things I would need to understand to build this manifest, for example, the environment variables, the spec, the location of the images, the ports, all of this information is just generated from the containers that I already have running. So as a developer, this is huge for me to not have to write this and simply be able to test my application. So I'm going to expose it locally. It's on this Kind cluster, and it's going to be on localhost port 9090. And let's go ahead and deploy it. So this is the same thing as doing a kubectl and applying this specific manifest, but I'm not having to go to VS Code, not having to go to the terminal. I can just click the button and it's deployed. So what's happening now is we're DDoSing the Wi-Fi here at the at the conference, and looks like it's fine. It already pulled the images down and they're running here in the cluster. Let's go ahead and check this out. So I'll go back to the control plane. We'll run that same command, kubectl get pods. Looks like both of them are up and running. Okay, good to know. So let's actually go and check it out in my browser. So I'll come back here and we'll hop out. There we go. So very cool, right? It's restarted. We've got our application running now, not only in pods, but actually in a Kubernetes environment. And this is great, right? Because our application's running, we could start adding different services to this local cluster. But the big part as a developer is, how do I get this off of my machine? And so at Red Hat, there's actually an extension for this developer sandbox, which if you're new to Kubernetes or you want to use OpenShift, this is a secret for free way to try out OpenShift and try out a Kubernetes cluster. And you actually get 14 gigabytes of RAM for free. So don't do too much Bitcoin mining. I know it's a high value right now. But you can actually try this out in order to deploy your applications to Kubernetes and share them with others. So this application that I'm working on, we've got it in Podman running locally. And now we've got it in a local Kubernetes environment. What I'm going to go ahead and do is come back here, or I'll just start it from the Podman version. And instead of using this Kind Kubernetes cluster, I'll come back and select another kubeconfig that I have, which is this developer sandbox context. And so you'll notice right now, if I go over to the Kubernetes tab, there's really not much going on, right? This is a brand new cluster. Looks like I've got one service for maybe hosting an LLM, for example. But when I come back here and we go ahead and deploy this to Kubernetes, you'll see we can create an OpenShift route, so it automatically creates a publicly accessible URL. And it was a lot faster right there. You know, we're connected to the internet, and we can just go ahead and open this up in the OpenShift console. So I'll head over to topology. Our pod is running, the same pod that we had earlier. We can view the logs, same logs that we had locally, and fingers crossed. Yes, sweet. So there we go. If you want to actually try out this application and get some handy links, I'll come back here. I have a QR code generator that's also containerized, you know. And let's see, hold on. Here's the URL, and I'll hopefully paste that in there. Cool. So if you want to see the application running that we were just working on locally, and now in a publicly accessible Kubernetes environment, you can just check out that link. It has some handy Podman Desktop resources that you can check out. For example, the community and everything. But as a developer, not bad, right? We've gone from our local source code to that Docker file to containers to pods to now Kubernetes. All of these different skills that traditionally we would have to master or we would have to be knowledgeable about are simply just a click of a button from this interface, which, you know, some people say, you know, should you use Podman? Should you use Podman Desktop? I think it's as simple as, do you use VS Code or do you use Emacs or Vim or something like that, right? There's an option for everybody. So this is a quick example of, you know, kind of the first part of the journey, right? Going from our local source code to Kubernetes, which is the title of the talk. But if you read the abstract, there's actually some other cool magic that we're going to be doing today. And you might have guessed it. It's the idea of transitioning to this new era of using AI and building AI-enabled applications. And so what's really great is that we were able to take our application and run it in a container and not worry about the dependencies, right? I don't have Flask installed. I don't have any of these dependencies, but I can containerize it. Well, with AI, we're able to do the same thing. We can take a model and we can take an inference server, containerize that, and not have to worry about any of the dependencies so that we can build really cool AI applications. So I want to show you a couple of these that are actually in containers, and they're actually really fun. But at the beginning, it all starts with enabling a developer to use the models. Do any of us, for example, use Ollama or have heard of Ollama before? Awesome. If you haven't heard about it before, it's another open source tool that allows you to run AI models. And it's a really popular tool, and it's almost 100,000 stars because developers are understanding that, hey, I can take a model, be able to run it locally, and not have to use a cloud service like ChatGPT or send my data to a cloud service. I can do everything local, just like I would with a database, for example, or test containers or something like that. So as a developer, it's really handy to be able to spin up a model. And we're going to show spinning up that model and actually building an application with RAG and with agentic functionality in the next demo. So I think it's going to be very fun. And for organizations, let's say you have sensitive data, could be PII data or HIPAA data, whatever it might be, you don't have to worry about it going to the cloud because it's all on premise. So an extension of Podman Desktop is this AI lab that bridges generative AI with containers and Kubernetes. And as a developer, it actually can kind of be a very overwhelming process to start using AI, right? You have to think about ideation and prototyping. Which LLM am I going to use? Is it DeepSeek? Is it ChatGPT? Is it Sonnet 3.7? And by the time this video will come out, I'm sure there's going to be another new model out there. And as well as that, you have to build and chain things together. How do you use your enterprise data? And how do you build this all into an application? And then on the other side, there's the operations side of serving a model and monitoring and all of that. But the idea is to simplify some of this as a developer so that you can one-click download a model, one-click serve a model, and use it in your application. So we're going to also experiment with this today in some of the demos. To do this, just as we had Podman Desktop for containers and Kubernetes, we also have the AI lab so that you can try out these models and you can inference them. And what do I mean by inference them? Well, a lot of us are familiar with Apache, for example, where you take your website, your HTTP, and you serve it, right? And so someone can connect to it, right? You're exposing it. So we're doing the same thing with a model. We're essentially using a runtime to expose it so that you can use it as an API. So I make a post request to the model, and I get that response back so that you don't have to run the model in your application. You just run it as a service. It's a black box. Stuff goes in, hopefully stuff goes out, right? So we're going to show this in action, and there's a lot of cool features, but I'll go ahead and run us to the demo. So as I mentioned, Podman Desktop, along with working with containers, Kubernetes, images, volumes, you can also work with the extension catalog, and there's a lot of cool stuff in here. Some of the stuff you might already be familiar with. I've installed pretty much all the extensions here, but the extension for AI Lab is really neat because as a developer, a lot of us are building out different examples of AI applications, right? They might be chatbots, they might be summarizers, they might be code generation, RAG, for example, stuff that is a pretty simple proof of concept for us, but actually as a developer can be kind of hard to get started with, right? So a lot of us aren't data scientists, right? We don't work with with models, or we don't work with a lot of these technologies that are new for AI. But we allow this to be simplified by these recipes so that you can package together all of the different components that you would need for a chatbot. And actually, we're going to check this out for RAG. How many of us have heard of RAG by chance? Awesome. Okay, you guys are the best. So RAG, if you haven't used it before, is a way to add your business data on top of a model. And so you're not changing the model itself, but you're adding this enterprise or unique data on top of it. So you throw a PDF at the model can answer questions from that PDF and give you a citation, which is really neat. Now, let's say we're building out a RAG application. I'm going to choose this model, for example. I'll explain what's happening here in a second. But to build out a RAG application, right, you need the source code for your app. You need a model server, and of course you need that model, connect those two together, and then say a vector database or some type of place to hold your data. Now, instead of having to do all this manually, what we do is we create a recipe or allow you to create your own recipe that packages all of these different ingredients together to make this one application, right? For a pizza, you need the pepperoni, the sauce, and I hope the cheese, Some people eat pizza without cheese. It's a little crazy. And the same thing is, true for an AI application. You need all those different components. So when I actually open this up, what we have is a vector database. So for example, ChromaDB running. And we also have a Streamlit application running. So something that can inference this model that's running in the background. Now, I'm going to ask a question that the model's not going to know about. I have I have some enterprise data that I want the model to know about. Let me see if I can find it. Here we go. So this is a funny example of Marty McFly, and this is his car insurance. He got in an accident, so his premiums are about to skyrocket. I feel bad for him. But this is something that a model wouldn't know about, right? It hasn't been trained on this specific information. And if I ask the question, what happened to Marty McFly in the 1955 accident, question mark? If we ask this question in the model, it's going to think about it. We're sending that request. It has no idea what happened. Blah, blah, blah. We don't have an answer back. What we're going to do is go and browse to this actual PDF. Let's see. There we go. And we're going to include this into the RAG application. So while this is processing, I'm going to explain what's happening in the background. And to do that, actually, I'm going to actually show you in VS Code what's happening here. So when I open up the source code here, this is that repository that was cloned. And this is really, really cool for me as a developer because this gives me a good starting point to build a RAG application. So some of the things that we're using are, for example, LangChain. We're connecting to that local model on port 8001. We're using an embedding model, which is going to take our data and convert it into vector embeddings. So we're able to search with essentially math scores to see what data is relevant. And we're essentially going to import, say, a plain text or a PDF document. We've got some information about the UI. We're populating the vector database. And we're giving the model a prompt. It's going to say, hey, based on this context, only answer if it's relevant, right? And we're essentially passing that prompt so that when we ask the question, we'll get that response back based on the similarity score of the data that was included. So I'll wait a second here as it's still kind of processing. Sometimes I pre-do this before because it takes a little bit longer, but there's a lot of ways to do a RAG pipeline in order to prepare your data for RAG. And that's a whole nother talk, but this is still a good starting point. In the meantime, while that's getting ready, I'm going to show you some other items that might be of use as you're going through and evaluating models and doing all of those different steps. Now, there's a really, really big concept that I want to explain when you're working with AI models, because there's a difference between open weight models and open source models. Because open weight, for example, with Llama, you're essentially past the final product of the model, the weights. It's simply like an executable file of the actual model. Versus if you're working with an open source model with perhaps Apache 2.0 licensing, you actually have a lot more permissions and freedoms to work with the model. And there's a little bit of a difference there. I think it's really handy for developers to understand that. So what we do is we package together a catalog of Apache 2.0 licensed models that you can use, for example, to work with text or to work as a code assistant or to fine-tune your own models for specific applications or to import them, such as DeepSeek, the reasoning model, and much, much more. So there's a catalog in order to do that, and once you're ready to actually run one of these models, well, that's just like an API, just as a model service is what we call it. So for example, the model that we have running in our RAG application now can be inferenced on a local port here so that we have a Swagger interface, for example, to ask questions. So let's try it out. Well, it thinks it's GPT-5 Turbo. Let's still try it. Okay. Capital Francis Paris. All right. Looks like it still works. So it's a simple way to kind of play around with your data. And at the end of the day, it's just an API. But let's say we're a Java developer, as we're going to see in the next demo. We could take some client code here to connect to our model, to add it as a dependency, and to create the service to actually make that request to the model. So this is done using LangChain for J, but let's say I'm a Python or PHP or whatever developer I am, you can get the starting point to start inferencing this model locally. And fingers crossed, okay, we've got the document uploaded to our RAG application. If we ask the same question again, the beauty of RAG is that this information is passed on top of the context that or as context for the question that you ask. And so it's going to retrieve that information from the vector database because of its similarity score and be able to provide that specific information back to the user or whoever is using this application. So it's a quick and easy way to kind of build out these AI-enabled applications. But a lot of developers aren't starting from scratch, right? A lot of us have existing applications that we already have running that we perhaps want to add AI capabilities to. Well, how do we see that in action? I've got my Java application to show you guys. So I'm going to open up that here in VS Code. Okay, so how many of us have used LangChain4j or heard of it before, perhaps? Sweet, okay. You guys are doing a great job with the workshop, maybe. So I'm going to show a quick example that you might have already seen before. This is using LangChain4j, so I'm going to just go ahead and start it up. It's a Quarkus application. So Quarkus is a framework for Java that's optimized for containers and Kubernetes. So it's a quick and easy way to set up a Java project and be able to do a live reload. So every change I make is automatically updated. And it's super handy for me because I'm not a Java developer, so I like to see things just updating and updating. And we're going to open this application up here in my browser. Now, this is Parasol. It's our fictitious insurance organization. So similar to how Marty McFly had his accident, well, we're going to up his premiums here in a second. Just kidding. But let's say we want to add a feature here to be able to help our insurance adjusters to process these claims, right? To be able to import the information from the claim from our customer and make our decisions more educated and more efficient for our insurance adjusters. So a lot of us are adding in chatbots, and a way to do that would be to use these locally running models to start iterating and testing and building out these proof of concepts. So what we're going to do, and you notice there is an error there, is we're actually going to copy in this specific code from the client code part of Podman Desktop, and I'm going to import this into my application. And we're going to try out our application again. But what's happening here is that we're opening up a WebSocket connection in order to directly talk to the model. And we're going to, if I do a word wrap here, provide some simple prompt engineering here. So you're a helpful assistant. You're going to be given a claim summary. What's that claim summary? Well, we'll pass it in as a variable from the actual claim. And we're going to add the question as well. So this is some, simple guardrails, and you could go a lot further with this type of example. But this is a quick way to start out. So we'll refresh the page. We're going to ask we could say, who is at fault here, right? To kind of understand, hey, what might have happened, who caused the accident, whatever question we want to ask here. And in the response, in the background here, we're actually getting all of these responses back as tokens, which is really cool. So at the end of the day, all we did was authorize a post request to the local endpoint that we have running that we saw in Swagger, and we're providing some information from the system message, the prompt template, and we're also providing the summary of the claim, some extra parameters such as temperature in order to make it a more definite answer. We could customize it like that. But in order to take a model that's running locally and start building these applications, it's a really, really easy way to start building out some really cool features that eventually I hope will help people save time and save resources and make the world a better place. So that's a little bit about integrating AI into an existing application. If you don't have an existing application, you can create a playground environment. One fun thing that I like to do is check out the reasoning model. Has anyone played around with DeepSeek? DeepSeek, for example? Okay. It's a funny model because, watch this question. I always try to ask, something that might get an interesting response back. So we're going to ask Vim or Emacs. And the way that it starts thinking is super, super interesting. This is before it actually gives the answer. And so it thinks through all of the responses. This is kind of chain of thought reasoning where it takes your prompt and it keeps on going with more examples. And I think it's just a really fun yapping model, I like to call it. So feel free to try that out and mess around with the playground environments. But this is the AI lab. And I want to show one more quick example because it's all fun and really interesting to do this from our local machine. But a lot of us have to take things into production environments. And I think that using containers throughout this whole process is really, really important because you're able to keep the same consistency and scale things when you're using containers from the beginning and when you're using containers at the end of the day. So a lot of us might have heard of, for example, NVIDIA NIMs, where they're working all within containers, for example, and they're working on these GPU workloads. But remember, I showed you that example running on my local machine. I also want to show you the example running in a production environment or simply a staging environment. So don't worry about this. This is Developer Hub. It's a simple way in order to kind of scaffold the application out so that all of our developers have the same guardrails and best practices, CI/CD pipelines, etc. But our container is also running, for example, in our Kubernetes environment. So this is on a cluster as well. We can see that we have kind of the same application running here. And we could ask the question as well. But before I show you that, I want to show you how we're running the models. Because at the beginning, we were using Llama C++. And this is the same runtime that Ollama uses, for example. But in production, we need to work with, for example, multiple GPUs or concurrent requests or being able to scale up and batching sizes and all of these other concerns that we have. So we have this way to use Kserve, which is a serving runtime for Kubernetes, and be able to scale up the model and be able to use it in production so that we can ask the same question. For example, who here is at fault in the accident, ? And be able to get a response back all within a Kubernetes native environment. So going from our local environment with containers to Kubernetes, from Podman Desktop to whatever cluster you'd like to use to run your models. So just a little tidbit about that. Now, I know we went a little fast in the presentation, but I want to kind of mention that whatever system that you're on, you're able to use your GPU to accelerate the inferencing speed of the containers. So on Windows, there's pass-through with WSL2. On Mac, there's something called libkrun, so you can use your silicon processing in order to speed things up. And Linux, you don't have to worry about it because that's the beauty of Linux. So highly recommend you check out the Podman AI Lab as well. That's what we went through on the latter part of the demo, but Podman Desktop in general, because it's a great way to work with containers, to simplify your life as a developer. And honestly, it's a project that I've worked on for a couple of years now, and I love it to death. You know, it's always what I've used to work with containers, and there's a great open source community behind it that is working to make it one of the most helpful tools out there for developers to use Kubernetes. Now, I'll be happy to answer any questions or run through any other demos, but I want to give you a big thank you for your time. I hope you enjoyed the session and enjoy Devnexus. Yes, sir. That's a great question. So the model is packaged in the inference server. So if I go back to one of these services that's running, we're essentially packaging up the right version of Llama C++ for your computer. So for example, this is Silicon, so it's a Vulkan version of the Llama C++. And then it's just being run in a container. So the model is being mounted to that container, and it's just serving the model like that. Yeah. Thank you. Great question.
Would you mind putting that first slide on with your QR code?
Yeah, I'd love to. One second. There you are. Yeah, if you want to check out the slides, please do. Yes, sir? 100%. So when we come back here, I'll connect to my team cluster. So any kube config that you might have, you can connect to, or you can add it from Podman Desktop. And so here I can see, here are all the nodes I have. If I'm connected to a project, I would see, like, one second, I'll show you. Come back here. So I can see, hey, here's all my deployments. For example, this is the application that we saw earlier. And I could mess around with the Kubernetes definition. So I want to change the name, for example, change the name, and then apply that to the cluster.
You said you sudo or root access to run this locally?
Yeah, so you can define whether you use the machine with root privileges. So if you don't, you would have some limitations. I think under port 1024 you can't use, for example. And there's some other differences, but if you're using it on a system that doesn't have root access, you can still run containers. It maps the user, the container's namespace to a non-root user, but it still makes the container think it's a root user. So you can still use like yum, or you could use DNF or whatever to install packages and do whatever you want in your container, but then it's being mapped to a non-root user on your host. So it's some interesting, low-level stuff that I don't really do too much, but it's really cool.
One quick question I have. I mean, for example, if I have some existing Spring Boot application,
Mm-hmm.
and I want to migrate to Podman, so what needs to be done? Is there any kind of migration steps you have?
Migrate to what, sorry?
I mean, like, the old applications, if I have, the prior Spring Boot applications, how to kind of, migrate those, in these, Podman, structure itself.
James, you might be more familiar. I'm not a Java developer as much. Yeah, sorry.